Now, we still hadn't done A. We hadn't finished it. Had we done much of anything? Okay. What were the transformations? Left 1, down 2. And then I told you to take the transformations off. Take off the left 1 and down 2, and what are we left with? We're left with y equals, if we take that off and take that off, we're left with log base 2 of x. Now, I told you yesterday that I was going to show you a different way to graph logs. You remember that? Now, we're going to see how it goes. Some students like the way I taught it the first way. Some students like the way I'm going to teach it to you now. And you're saying, I don't remember the way we taught it the first time. Question? So, what I told you was, if we will just rewrite this as an exponential, that'll be 2 to the y equals x. Now, if all we did was a rewrite, correct? We didn't find an inverse. We just rewrote a log as an exponential. So these mean the same thing. We're good there? Now, so what we're going to do is we're going to make our table for the log off this, and then we're going to move it. Notice, what's the exponent? What variable's in the exponent? Y. So guess what? We're going to have to put numbers in for y, because y is the exponent. -2, -1. Go that way. Whatever is the exponent, that's where you're going to put your numbers. Okay, well, start big. 2 squared, 2 to the first, 2 to the 0, 2 to the -1. That is on the parent function. Those points are on this, right? And then I'm going to transform. Any of you ever play with those transformers? Okay. Now, remember, so what are we going to do? Left 1. What does left 1 do? Do x minus 1. Now, if you can't do that in your head, you do that on the calculator. What's a fourth minus 1? Do it on your calculator. Not -1. Be -3/4. Half minus 1, 1 minus 1, 2 minus 1. 1/4 minus 1 would be 1/4 minus 4/4 to get a common denominator. So it'll be -3/4. And what do the y's do? Subtract 2. -2 minus 2. Aha! -2 plus 2 is 0. -2 minus 2. -4. Keep going. -3. -2. -1. And 0. And you plot them. -3/4. -4. 1, 2, 3, 4. -1, half -3. 1, 2, 3. 0, -2. 1, -1. 3, 0. Okay. I'm going to ask you a question first. Where's the asymptote? Now, what kind of asymptote does a logarithm have? A vertical one. Good. A vertical. Now, if at a vertical asymptote. Now, if I move a vertical line down, does that change anything? No. If I move a vertical line left one, so what is my vertical line now? It's not x equals 0 anymore. It's x equal -1. So your vertical asymptote is x equal -1. You're gonna dot that sucker in, and then you're gonna draw your logarithm. And there's your logarithm. All right. Okay. Now we've got 3 on this page. Let me see what they are. We got to do C. Do we got to do B? How many? Oh, just hush. No, I'm talking. No, it's all right. Okay. Does it say to do in behavior? It says to do in behavior. So let's not do in behavior on all of them, because I feel like you're getting pretty good at that. All right, let's look at B. Let's look at B. What are the transformations on this one? Good. Vertical stretch by a factor of 3.
Right.
And right 2. It's your watch. All right. Now let's talk for a minute. What does vertical stretch by a factor of 3 do? Multiply what by 3? The y values. What does right 2 do? What does right 2 do? Add 2 to the x. Yeah. Okay. So now we're going to take off the transformations and figure out what our parent graph is. Take off the moves. What are we left with if we take that off and that off? Log base 2 of x. Now let's rewrite that as an exponential, just a rewrite. 2 to the y equals x. Remember, just a rewrite. Uh-huh.
So every single one you're going to rewrite it?
That's the other way to graph a log. And for some of you, this may be a whole lot easier than the other way I showed you. All right. We're going to find points on the parent graph because remember, these two mean the same thing. Where do I put my -2, -1, 0, 1, 2? Why do I put it as y? Because the exponent is y, right? Because the exponent is y. -2, -1, 0, 1, 2. Aren't these the same ones we did last time?
Yeah.
Well, daggum. Okay. All right. 4, 2, 1. Are you using what? Half, fourth. And now we will transform. Hey, go LSU. So excited they won last night. Don't. Yeah. Oh, wait. Okay. Now, what's the matter? Okay, just checking. Vertical stretch by a factor of 3. What does that tell us to do? Multiply what? The y value by 3. And what I got to do here? Add 2 to x. So I got one thing to do to y, I got one thing to do to x. All right, let's do x first. Let's move x right 2. A fourth plus 2 is 2 1/4. A half plus 2, 2 1/2. 1 plus 2, 2 plus 2, and 4 plus 2. Now what are we going to do to the y values? Multiply by 3. -6. -3. 0. 3 and 6. Plot them. Plot them. -2. Excuse me. 2 1/4. -6. 2 1/2. -3. 3 0. 4 3. 6 6. Earbuds out. Do your work. Guys, I don't want any earbuds. Let's talk about that dadgum asymptote. Well, not 3. Yep. That asymptote was at x equals 0. Now it's at x equal 2. So your vertical asymptote sitting right here at x equal 2. 2 at 2. And draw your picture. Why is this one so stretched out? Because dadgum, it's got a vertical stretch on it. Are you doing okay? Doing okay? Okay. Let's do the, I know, oh my God, I know. F of x approaches what? As x approaches 0. Not 0 this time, is it? As x approaches 2. So as the x values get closer and closer to 2, negative infinity. F of x approaches what as x approaches infinity? Infinity. And beyond. And beyond. Okay, we got 2 done. Now we're going to do this one because this one has a negative in a weird place. We got it. What's that negative do? Reflects over the y-axis because it's in with the x, so it lies. Reflects over y. Oh, wait. But if a logarithm, which normally looks like this, reflects over the y-axis, what's it going to look like? It's going to look like that somehow, right? Okay, so just keep that in your brain. What else? What other? Up 4. Take out the transformations. What's our parent graph? Well, snap. Huh? Y equals, yeah, you're all right. Y equals what? Log? That's parent. Rewrite it as an exponential. 3 to the, with y equals x. Now remember, we just did a rewrite. These are the same thing. So when we do our table, where are we going to put our -2, -1, 0, 1, 2? In the y, because the y is the exponent. Okay, you got this. You got this. Okay. 3 squared. 9. 3 to the first.
1/3, 1/9.
And now for the transformation. You ready? Reflect over y. What changes? The sign of the, look here, these are reflected over the y-axis. Yeah, that went from 3,1 to negative 3,1. What changed? The sign of the x value. So, look here. Up 4, what's up 4 do? Add 4 to y. There you go. So we're going to switch the sign of the x. Do that. Oop. And what are we doing to the y's? Add 4. Help me, I don't think I remember how. Negative 2 plus 4? Good, go. Okay, plot them. Negative 1/9, 2. Negative 1/3, 3. Negative 1, 4. Negative 3, 5. And I can't see. Come on. Negative 9, 6. 2, 3, 4, 5, 6, 7, 8, 9, 1, 2, 3, 6. Do you have to count to 9? Oh, it'll help. Excellent. Let's talk about that asymptote. Was it x equals 0? Did we move left and right? Nope. So where's the vertical asymptote? Still at x equals 0, it didn't move. So that vertical asymptote's still right there. And then, woohoo. Vertical asymptote, still x equals 0. Is this making sense? Here's what I need. I'm pretty good with you. Sort of. And then down here is I'm just really struggling here. Okay. All right. Okay. The thumbs are anywhere between here and here, so I can deal with that. Okay. Okay. There's 3 of them here. Let's do. I agree. Let's do B. We'll do B and C. We'll do B and C. And what I'll do then, that we should be done with that by 9:30. That'll give you 25 minutes. And any of you who just want some extra help with me, we can small group up and we can work some more, okay? On B. What makes it look hard? The fact that it's a base of a half? Yeah, you got this. What are the transformations? Eh? What? What's this? Reflect over the x-axis. A negative is a reflect. End of story. Reflect.
And then right one.
Good. Reflect over the x-axis and write 1. Before we go anywhere else, what does write 1 do? X plus 1. What does reflect over the x-axis do? agree that it changes the sign of the y value? Okay. Are you struggling with this because there are so many steps? Okay. Take off the transformations. What are we left with? Y equals log base 1/2 of x. Good. Rewrite as an exponential 1/2 to the y equals x. Didn't, why are you using parentheses? I typically will use parentheses when I have a fraction. Table. Why do the numbers go in the y? Because y is the exponent. All right, you can do. You got this. You can do this. What's 1/2? We're going bottom to top. What's 1/2 squared? 1/4, because it's 1 squared over 2 squared. 1/4. What's 1/2 to the first power? 1/2, because what's anything to the first power? Itself. Anything to the 0 power is 1. Okay. A negative exponent means, remember? Flip it. 2. That's going to be 2. It's going to be 2 over 1. Flip it. 2 over 1. And this is, flip it, 2 over 1 squared. 4. See, you did it.
Now you got a transformation.
Yeah, but that's all. That's easy. Transformation.
-4.
What do we say about the x? What do we got to do? Reflect over the. Oh, hold it. What do, change the sign of the y. Okay, so let's change the sign of the y.
So 2, 4, 0, -1.
And add 1 to the x. Add 1 to the x. Don't plot them yet. Don't plot them yet. I want you to think in your brain. Okay? I want you to think, if we had a logarithm, just a normal logarithm, but we reflected it over the x-axis, what does it look like? Yeah, our answer is going to look like this somehow because we're reflecting this over the x-axis. So just keep in mind what you're expecting. And if you don't get what you expect, then something wrong. Plot them. Go. Yes. What did I do wrong?
Oh, well, you put 1 over. Yeah, that should be 2.
Yeah, that's 2. Thank you.
That's extra.
Yep.
Hey, we should have got.
Hey, yeah.
For what?
Whatever.
Will you correct?
Let's plot them.
Okay, wait. This isn't making sense.
Huh?
Unless I'm plotting these wrong, this doesn't make sense.
Let's see.
It's still going this way.
Let's see here. The problem was 1/2 to the, oh, hang on. Hang on. Here's the issue. Look at what our base was. Am I recording this? Yes. Did you see that our base was 1/2? When the base is between 0 and 1, we have exponential decay, right? So it's going to look a little different. In fact, the logarithm would look like this. So, give me a minute. Plot them. We're right. We got it. What I said before was this, but that's if the base is bigger than 1. Just humor me, I promise. I'll get you. 5, 2. 1, 2, 3, 4, 5, 2. 3, 1. 2, 0. 1 1/2, negative 1. 1 1/4, negative 2. Where's my asymptote?
1.
What equals 1?
X.
Vertical asymptote is x equals 1. Graph goes right like that. Can we come up with some steps? Would it help you if we kind of wrote down some steps? No? Would it help anybody if we wrote down some steps? No? Well, all right then, fine.
I understand it, but
Okay,
how you said the first time that it was supposed to go like this.
okay.
So that's why it didn't make sense.
1/4 minus 3 is negative 2 3/4. Thank you. 1/2 minus 3. Negative 2 1/2. 1 minus 3. 2 minus 3. And 4 minus 3. Subtract 5 from what? The y. Yes. Plot them. Negative 2 3/4, negative 7. Negative 2 1/2, negative 6. Negative 2, negative 5. Negative 1, negative 4. And 1, negative 3. Hey, we're doing pretty good. Where's your asymptote? What equals negative 3? Your vertical asymptote is x equals negative 3. I meant to do that in yellow, but oh well. Let's, yeah. You're reading my mind. Tell me this. Why do you think I put negative 3 right here? That's your vertical asymptote, and as you're moving left, do we go past negative 3? The graph is not past negative 3, so we stop there. So as x approaches negative 3, what do the y values do? Go to negative infinity. And as x approaches infinity, infinity. Yeah. If you can do this, you can do anything in Algebra 2. Yes? Yes, I do. All right.